Good afternoon, class. This is Mrs. Bullard, and I'm going to walk you through your notes for today before you start on your practice. On Friday and on Monday, we looked at hanging diagrams. So our goal is to keep these diagrams balanced, and right now this one is balanced because the top is even. And Elena wants to know if she takes two triangles off the left side, so she wants to take these two triangles off the left side, and three triangles off the right side if it will stay balanced. And the answer is no, it won't stay balanced because you have to add or remove the same number of each item, each like thing from each side. So if I only remove two triangles from the left, but I remove three triangles from the right, then it will tip to the left side because I've removed less from that side. So we can use these hanging diagrams in order to solve equations, and that's our goal today, to solve equations. And when I say solve an equation, we want to find the value of unknown variables in this case, or we can think of them as shapes like squares. So we can write an equation to model the weight of each square. We don't know how much the squares weigh, but we know the triangles weigh 3. So we can say this is x plus x plus x plus 3 plus 3. So that's what I've written on the left side. And then on the right side, there's only one x, the square, plus 1, 2, 3, 4, 5 of the 3 grams triangles. So now what I'm going to do is combine my like terms. So these three x's are like terms, so they're 3x, and 3 plus 3 is 6. There's nothing like the x on the right side, but there are 1, 2, 3, 4, 5 threes, so I add all my like terms together to get 15. So that's step 2. And all I've done is combine my like terms. Now when I have variables on both sides like this, my goal is to move all my variables to one side and all my numbers to the other. So what I did here was I took this 6x, or just the 6, and I subtracted it from both sides. So that's like removing it. And if I take it away from the left side, I also have to take it away from the right side. In the final step, I see that 3 is being multiplied by x. So I want to divide both sides by 3. So essentially what we're doing is we're looking at what is happening to the variable, and we want to undo what's happening. So if we see something is being added, we want to subtract that. So the opposite operation, it's called an inverse operation. And if we see that it's being divided, we want to multiply, or if it's being multiplied, we want to divide. So here's an example without the hanging diagrams, just from an equation. These coefficients are rational, which means they're, in this case, they're fractions, but they're just any number. They can be positive or negative, and they can be whole numbers or fractions. So let's try to solve it. I notice there's no like terms on my left and no like terms on my right. So what I want to do is move all my variables to one side and all my numbers to the other by using inverse operations. So in this first step, I want to undo subtracting 2/5 x. So I'll add 2/5 x to both sides. And in this case, 2/5 plus 1/5 is 3/5. It's okay if you use a calculator, but in this case, because the denominators, that bottom number, are the same, then I can just add the top number. 2 plus 1 is 3. Now I want to take all my numbers and move them to the other side. So I just have the variable and the coefficient on one side. So I can subtract. Instead of plus 1, I can do minus 1, and I have to do it to both sides or else it will become unbalanced. And finally, I need to undo multiplying by 3/5. So the inverse of 3/5 is 5/3. So I'll undo that. And maybe you've heard keep, change, flip before. So we want to keep the multiplication, or keep the first 3/5, change, divide to multiply, and flip my operation. So that when I'm multiplying by this inverse, it just becomes x on the left, and negative 3 times 5 over 3 is negative 5 on the right. Okay, so there are multiple ways to solve equations, so I just want to give you a few more examples before I let you practice. So in this case, when we have something that looks like this with something being divided, I can either divide 12 and 6 by 3, which is what I did in method A. 12 divided by 3 is 4, 6x divided by 3 is 2x, or I can undo dividing by 3 by multiplying by 3 on both sides. So what I've done first in method B is I multiplied by 3 on both sides. That's where this negative 6 came from. That's negative 2 times 3. And then after that, we do the same thing as before. We think if anything is being added, we want to subtract that. So in the second step, we subtracted 4 on both sides in method A, and we subtracted 12 on both sides in method B. And then we want to think, is anything being multiplied by x? If so, let's divide that. So in method A, we divided both sides by 2, and in method B, we divided both sides by 6. Okay, and lastly, I want to explain our justification for these steps. So there's really only a few that you'll work with today, and they are down below. This can be your word bank as you think about how you are solving equations today. So in this example, the first step I listed was the distributive property. That's the first thing I did. I distributed or multiplied 1/3 by 6x and 1/3 by negative 54. And then I used the subtraction property of equality that says I can take away the same thing from both sides. So in this case, I took away x from both sides. And then I used the addition property of equality by adding 18 to both sides. And again, my goal is to get all my variables, all my letters on one side, and all my numbers on the other by using inverse operations. Notice that in the first step, I subtracted x because it was positive originally. So the opposite of positive is negative. The opposite of adding is subtracting. That's why I subtracted x from both sides. And in this second step, I added 18 because adding is the opposite or the inverse of subtracting. And that's how I got my answer of 14 is equal to x. So today what I want you to work on is solving equations with variables on both sides. And these are all the answers that you're going to get today. These are all the numbers that you should get. You know you're correct if you get an answer that's on this piece of paper here. Notice that some of them are decimals and some of them are fractions. You may use a calculator to help you. And when you finish, you can match up whatever number. If you did number 1 and you got 8, then in the blank where it says 1, you'll put the letter E. And you should get words at the end of the day. Okay, so I want to give you a little bit of help on this activity as you go through it. For the first 4, they're all pretty straightforward. We want to take all of our variables and move them to the one side, and take all of our numbers and move them to the other sides. And be sure that if things are being added, like this 15 is being added, so if I want to move that 15 to the other side of the equal sign, I need to use the inverse operation, which would be subtracting 15. Don't let the fractions scare you. Again, you can use your calculator to help you, or because they're common denominators, you can think about just subtracting or adding the numerators. Do notice there is a 1 and 1/3. That's the same as 4/3. If you want to change that to 4/3, that might be easier to work with. These next 2 are word problems, so you'll have to read this and see if you can come up with an equation. The fee of $500 is what he has an annual membership fee, and then it cost him $35 a round. And without the membership, they charge $55 for each round. So he wants to know how many rounds for them to be equal. Okay, so 500 plus the 35 per round on one side, but we don't know how much the rounds cost, is equal to 55 per round on the other side. A reminder about the word perimeter. Perimeter means all the way around, so we're going to add up these expressions, x plus 6, x plus 9, and x plus 3 on one side of my equal sign, and on the other side I want to do x plus 4, x plus 1, and then x plus 4 is the top and x plus 1 is the side over here. So I can set those equal to each other and try to solve. 9 and 10 also are talking about perimeter and a word problem, so try your best with those. And then 7 and 8 again are just we want to add or subtract our variables to one side and add or subtract our numbers to the other, and then multiply or divide to undo our coefficient and to get x or y, whatever variable, by itself. Okay, and then in the end, you should get a word or a phrase down here, and that's how you know you did it correctly. Please make sure your name's on your paper and turn it in at the end of class.